Assalamu alaikum, greetings and everyone. My name is Musa Bojang and I'm presenting for my assembly language individual assignment. First of all, I would like to run the program. Okay, I'm gonna go start without debugging. This is the first interface I got. So I have two options at this stage. I can either go to chapter 6 or chapter 7, but I'll start with chapter 6. So press 1. So chapter 6 has 5 more subcategories: the Boolean, the jumps, the loop, then the structures, control flows. So we go first to the Boolean instructions. So in these Boolean instructions, we have the AND, we have the OR, we have the XOR, we have the NOT, we have the test, and we have the CMP. So briefly, the AND OR operation and the test is similar. The only difference is that the test does not change the value of the first operand. The CMP basically compares the operands or the registers. So let's see what this does, the AND operation. So we are going to perform an AND operation with this value. This value here in binary, which is equivalent to 32, 16, 1 is 49. So let's say I enter 44 in binary. So it's sorry, in decimal. It's going to be converted in binary and then AND with this value. So this will be the final result. So let's say we do the same thing for the OR operation. Same number for the sake of simplicity. And we have a different result in this case, this one. So, and the third one is the XOR. So I use the same number again, and we have different results as well. So for this case, for the next one, which is NOT operation, it's a negation. So whatever value I enter, it should give me the opposite of that. Let's say in this case I enter -3, I should get +3. Okay. Let me try again with a positive number now. 4. So let's say +8, I should get -8. That's okay. So we go to the test instruction. So here it says that it already gives us the value. This is odd. It's an odd number. So basically, like I explained before, the test works the same as the AND operation. Only difference is it doesn't change the first operand, the value in it. Okay, the first register. So we are going to use this program to check whether a number is even or odd. So, and this code is implemented so here the code is actually implemented here. You can see this. This is from the Ivan library, write string, prints the string here. This is what we have here in the string. So we move the 9, okay, because 9 is an odd number. Even definitely it's not even. So if at all we change the 9 here to 8, we should get a new value, right? When we run the program again, we should get a new value. Let's see how that goes. Okay, so you can see we do the test, and then let me close the program, and then we do it again. Okay, so 1 Boolean test 5. So now this is an even number, because definitely 8 is an even number, right? So the next one, we go to the CMP. So like I said, CMP basically compares registers or memory operands. So it has already been implemented in the code several times. We just need to refer to the code. So like here you can see the CMP is used to compare the EAX, which is from the input value, with 1. So if it's 1, it goes to this label. If it's 2, it goes to this label, which is from the main menu, right? So we are done with the subsection of Boolean. We can now go to other places. So let's say the jump. So the jump, there are several jumps. We have jump based on specific flags, and based on equality or inequality sign and unsigned comparison. We're gonna make this one quick. So jump based on a specific flag. So this one, it's based on a 0 flag, so it's going to jump if it's equal to 0. So in the code I have implemented for the number to be subtracted. That's why I ask here to enter number 3. So once you enter 3, it's going to make 3 minus 3, and definitely that is 0. So it's going to jump and indicate that this value is 0. So the jump flag has been indicated. So the next one is the equality sign, right? So it says this one has been implemented at these lines. Actually, they have been implemented a lot also. So like here, the moment I make a CMP comparison, if it's equal, if it's true, it has to jump to the chapter 6. So this one is the jump based on equality or inequality. So jump based on sign or unsigned. So this is basic simple comparison. So if let's say I enter a number that is less than, it asks me here to enter a number greater than 5. Let's say I enter number 3, it is definitely not greater than 5. I enter 5. 5 is still not greater than 5, but let's say I enter 6. So it does give me another value saying that the number you entered is greater than 5. So that's it for the comparisons. We can go back to the main. Okay, no, now we go to the loops. So for the loop, what is happening here? Maybe I should show the code. So what is happening in the loop? Actually, we have some array. We have an array of numbers, most of the numbers are negative numbers. So this loop is going to perform a loop between these arrays, and it's going to look for the first positive number, which in this case is 20. That's why we have a value of 20 here. So you can see we declare the array here, and here is what we do, and we're using tests to test the value and also the stack functionality. So we push to the stack. So this is where the loop happens. It's going to loop if not 0. So it's going to loop until it finds the first positive value and then prints that one to the screen. Actually jumps to the label. So number 4 is the control structures. So these ones, they have been implemented in the code, and it's similar to the control directives. They have also been implemented in the code. So one example would be like this: an if statement and an if statement. So here we can have an if statement. If EAX is equals to 1, jump here. Else if. So we have a bunch of else if statements here. So that one demonstrates the structures and the control flow directories. Now we go back to the main menu and enter chapter 7. So chapter 7 has just 3 subcategories, namely shift, instructions, and its application and multiplication. So this one is going to be quick. The shift instruction here is going to shift using left shift. So whatever value I enter here is going to be shifted I think 3 times, yes, I can remember. So it has been implemented in the code to be shifted 3 times. I'm going to enter 5, which will be 0101, right? So 5, when shifted, this will be the value in byte. So let's go to the next one, the application. We are going to apply using its application using we are going to make application using binary multiplication. So whatever number we enter here has to be multiplied by this 36. So, and the result will be in binary like this. And the last but not the least is multiplication instruction. Specifically, we are using MUL. There is IMUL and division, and yeah. So there are several for sign and unsigned. So this one is for unsigned. So whatever number we enter here will be multiplied by 10. In this case, if I enter 6 times 10 is 60. So we should have 60 as our answer, and 4 to go back to main menu, and it only has one exit to terminate the program, which is 3. So thank you for watching.